Okay, welcome to 3-2, solving linear systems algebraically. By the end, you should be able to use the substitution method to solve linear systems. So by the end, you should be able to use the substitution method to solve linear systems. And the definition of the substitution method is just solving one of the equations for a variable and substituting that into the other equation. And the definition of the substitution method is just solving one equation for a variable and substituting that in to the other equation. And these are your steps to solve. So like I said, one equation must be solved for one of the variables. It doesn't matter if it's x or y. And then you'll substitute what you solve for into the other equation. And make sure you use parentheses. And then you solve for the remaining variable. And after you solve, you need to plug it back in to one of the original equations, solve for the next variable, and then you'll have your answer as an ordered pair x and y. Okay, let's take a look at this example. Let's look, we have two equations. We have y equals x minus 1, and we have 2x minus y equals 4. So step 1 said one equation must be solved for one variable. That looks like equation 1. It is solved for y, so we know what y is. Y is x minus 1. Alright, so substitution method says plug this in for y into the other equation. Okay, substitute x minus 1 for y into x minus y equals 4. So then we'd get 2x minus x minus 1 equals 4. Distribute the negative and we have 2x minus x plus 1 equals 4. Combine like terms, subtract 1 from each side, and we get x equals 3. Okay, now we need to plug x into one of the original equations and solve for y. So we're going to plug it back into our first equation. And if we did so, we would have y equals 3 minus 1. And that means y equals 2. So our ordered pair would be 3, 2. Now we need to check our answer. So let's plug in 3, 2 into the second equation. So 2 times x, which is 3, minus y, which is 2, equals 4. 2 times 3 is 6, minus 2 equals 4. And yep, our ordered pair works. Alright, let's look at this example. Well, we can't really see it, so I'm going to rewrite it. It's 3x plus y equals 17, and 5x minus 2y equals 10. So step 1 said that we had to solve one equation for one of the variables. So since I see that this y has a coefficient of 1, I'm going to solve for y in the first equation. So if I subtract 3 from both sides, I get y equals negative 3x plus 17. Okay, now I have my y, and I'm going to substitute it in for the other equation. So then I get 5x minus 2 times y, which is negative 3x plus 17, equals 10. Now I'm just going to distribute. So negative 2 times negative 3x is 6x minus 34 equals 10. Combine my like terms. I get 11x minus 34 equals 10. If I add 34 to both sides, I get 11x equals 44, and so x equals 4. Now that we have x, we need to plug it back in. Let me find an eraser. To one of our original equations. So I'm going to erase so I have room to substitute back in. Okay, good enough. I am going to substitute it into the second equation. So I get 5 times x, which we said was 4, minus 2y equals 10. 5 times 4 is 20, minus 2y, negative 2y equals negative 10, and y equals 5. So now we have our ordered pair, 4, 5. Now let's check our ordered pair. So I'm going to erase again. I know it takes a while. And I'm going to check and see if it works. So I want to plug it into my first equation. 3 times x, which we said was 4, plus y, which we said was 5, equals 17. 3 times 4 is 12, plus 5, and it looks like our ordered pair works. Okay, I want you to try this one on your own. As you can see, the first equation is solve for x, so you'll need to plug that in for the x in the second equation. So pause the video and good luck. So hopefully you got the ordered pair. Oh, I need a pen. Negative 58, 15. If you didn't get negative 58, 15, go back and check your work. Hopefully you can find your mistake. If not, you can ask me about it tomorrow. Okay, here's another system of linear equations, and our second equation is solved for x. So I'm going to plug that into the first equation. So I get 6 times 5/3 y plus 2 minus 10y equals 12. Distribute, and I get 10y plus 12 minus 10y equals 12. If we combine like terms, I have a 10y minus a 10y, so that reduces to 0, and I'm left with 12 equals 12. Well, this statement is always true, so that means we're going to have many solutions. We don't have to substitute it back in or anything. We can just stop there knowing that we'll have many solutions. Okay, here's another example, and I can bet you already know how it's going to turn out. So I'm going to substitute in to the second equation for x, and I get 2 times x, which is 2y plus 3, minus 4y equals 7. Distribute my 2, so 4y plus 6 minus 4y equals 7. Combine like terms, that reduces to 0, so I get 6 equals 7, which is a false statement, and we don't have to substitute back in because we already know there's no solution. Alright, just as a recap, step 1 was to solve one of the equations for any variable. Right, you can do x, you can do y, and usually it's given to you, and that's why we want to use substitution. Step 2 is to substitute. Into the other equation. Step 3 is you solve after you substitute, and then you'll need to substitute back in to the original equation, and then you'll need to solve, and you should have an ordered pair XY as your answer. So bring your questions to class and we'll work out a few more examples so we get the hang of it.